चावल में पानी डाल दूंगा ऐसे। So hi everyone, thank you for coming to my talk. Today I'll be talking about some work that we've been doing on learning to classify from natural language explanations. So if you think of the last 2 decades of NLP research, almost all of it has been about how can statistical learning be leveraged to improve the state of natural language understanding. So the work I'm going to talk about today actually explores the opposite question, which is whether natural language interactions can actually help machines learn better. So before I begin, I'd just like to mention that this is joint work with my collaborators, Igor Labutov and Dr. Tom Mitchell at Carnegie Mellon. So imagine that you want your personal mobile assistant to manage your important emails. So for example, you might want it to send you a reminder if you haven't read an important email for several hours. So in order to be able to do this, the agent would first need to understand what's this notion of an important email and how would it know this. So ideally you should be able to explain to the agent what an important email might look like so that it can then use this information to decide if a new email is important or not. So for example, you might want it to say things like, emails from my boss are usually important, such emails mention a deadline or a meeting, the subject might say urgent and so on. And in essence, this is the problem that I'm going to talk about today, which is how can you learn classifiers for concepts such as important emails from natural language explanations which look like these. However, before I get into the technical part of my talk, I'd briefly like to motivate the faith which fuels much of this research, which is that language can make machine learning more efficient and natural. So usually when we think about machine learning, at the back of our minds, we are thinking of large collections of passively acquired data, or what is colloquially called big data. And this is a very good reason. The inductive learning paradigm has been widely successful across a range of application domains. However, it does have some disadvantages. Most notably, this kind of big data might actually be infeasible to be collected for the long range of real world learning tasks. And this is because real world learning scenarios are often domain specific or even individualized. So for example, my notion of what's an important email might be different from yours. Secondly, there are inherent statistical limitations on what can be learned from labels alone. So learning theory tells us that the number of examples you need roughly scales as the log of the size of the hypothesis space. And technically, this should make learning of even common knowledge representations like ontologies impossible. And this is obviously bizarre. Children can and do learn these representations with limited or very little labeled examples. So the reason for this dissonance might be that traditionally machine learning has largely ignored richer forms of input than examples. So if we want to make machine learning as effective as human learning, we need to think of ways through which machines can learn in more human-like ways. So consider the ways through which children learn. They do learn from labeled examples and observation, but they also learn from a blend of other strategies. For example, explanations, instructions, clarifications, and so on. So in particular, if you think of human learning and teaching, much of it seems to revolve around activities which are very intimately connected with language. So these are things like reading books, listening to lectures, engaging in student-teacher dialogue, and so on. But the bigger reason why we should care about teaching computers using the language of humans is that if we could in fact do this, computers could be way more useful than they already are. So just imagine the sorts of things that might be possible if we could teach computers to classify using language. So for example, you might say things like, if there's a new publication relevant to my current project, email it to me. Whenever the weather is going to be bad, let me know a day before. Or if I receive a late night email from my advisor, ring the alarm at full blast. And so at the heart of all of this is that rather than wait for a developer to develop these software capabilities, instructing machines using language can potentially make every computer user a programmer. So we believe that there's two core issues in learning from language. And the first is the issue of language understanding or semantic parsing. That is, how can we learn to map free-form language, such as this, to some kind of symbolic representation, which in some sense represents its meaning. And this process is usually called semantic parsing. The second question is, what are the basic mechanisms, even if you could completely interpret language, what are the mechanisms through which these interpretations can operationalize learning? That is, even if you could perfectly interpret explanations like these to symbolic representations like these, how do these help you actually to learn a classifier, a concept model or a classifier for something like important emails? And so the second part is actually learning machine learning models or classification models for concepts. So in my work today, I'll be talking about both these two aspects, but I'll mostly be presenting two distinct ways through which natural language can operationalize learning. And these two aspects constitute the two parts of my talk. So first I'll talk about some work on how natural language explanations can be used to define rich and expressive features for all sorts of classification tasks. And in the second part of the talk, I'm going to talk about how declarative knowledge can be conveyed through natural language, and this can be used to directly drive or supervise the training of classification algorithms. In particular, this can be used to train classification models with limited or even no labeled examples. So the first part of the talk appeared at the paper at EMNLP last year, and the second part appeared at ASIL earlier this year. So let's begin with the first part of my talk, which is about how natural language can be a very natural medium to specify features for interactive feature space construction